How did he get into this?
All right, number 1 on the group quiz. Y equals 5 to the x power. Most of you know that this is an increasing graph, which means it's going to end up going like this. Okay, it's always going to hit at the point 0, 1. And is it ever going to hit the x-axis?
No.
No. You could, if you wanted to, make a t-chart with x and y, and you could choose like -1, 0, and 1. If you go 5 to the -1 power, that's going to be 1/5. 5 to the 0 is 1. 5 to the first is 5. So see, over 1, up 5, it's around that, how that graph looks. Okay? Y equals 1/3 to the x. Same idea, when you have a third, it keeps dividing, so it keeps getting smaller. So this is a decreasing graph that looks like this. Again, it's going through the point 0, 1. Is it ever hitting the x-axis? No. And you could also have done a t-chart with x and y and use -1, 0, and 1. When you have 1/3 to the -1 power, that ends up making a 3. 1/3 to the 0 is 0, and 1/3 to the first is 1/3. Okay, questions on 1 or 2? All right, example 3 says, given the equation y equals x to the n, where 0 is less than x is less than 1, and n is greater than 0, which statement is true? So we need to choose values and plug it into that equation. So it is telling you that the x value is in between 0 and 1. So what values are in between 0 and 1? Fractions. So we would choose something like 1/2 for x. And it says n is greater than 0. What is a value that is greater than 0? 1. So we're taking 1/2 and we're raising it to the first power, which makes the answer of 1/2. Does that equal 0? Is 1/2 less than 0? Is 1/2 in between 0 and 1? Yes. Is 1/2 greater than 1? No, and it's not undefined. The only answer that even works is C. Questions on 3? Okay, 4. If the equation y equals 7 to the x's graph, which of the following values of x would produce a point closest to the x-axis? So again, this graph is increasing. It looks something like this. So what values are going to be closer to the x-axis? As it goes this direction, going this way, it's getting closer and closer to the x-axis. Good, negatives. And it would end up being the largest negative values, right? But the largest negative value on this is -1. So that is my answer. Number 5. This one we have y equals 1/2 x to the x power. And again, they want to know which one produced the value closest to the x-axis. So this graph is decreasing and looks like this. So it's getting closer and closer to the x-axis as it is going right. So what values are going right? Positive values. So you want to see which positive value is the biggest. A is 1. Negative, definitely not. 0, no. And this, if you change this, this is 2.5. So which one's bigger, 1 or 2.5? 2.5. Good. So C is the answer. Number 6. One certain element decays over time with a half-life of 1,600 years. Use the formula to determine how many grams will remain after 3,200 years if 300 grams are present initially. Okay, so what is my A value? Good, my A value is 300. So I'm writing 300 times 1/2 to the T. What is my T? Time in years that has passed, which, good, 3,200. Divided by my half-life, and what is my half-life? 1,600. And if you reduce that, we can cancel out zeros, and 32 divided by 16 is 2. You always do your exponents first. 1/2 to the second power is what? 1/4, because 1 times 1 is 1, and 2 times 2 is 4. And then you end up with 300 over 4, which reduces to 75. And you could do long division there. So my answer is 75 grams. Questions? Okay. Number 7. How do I get rid of a exponent? Good, reciprocal. So in this case, my reciprocal will be 3 over 5. And whatever I do to one side, I have to do to the other side. So these all cancel out. 32 to the 3/5. How do I rewrite that? Perfect. What's the 5th root of 32? 2. And then 2 to the 3rd power is 8. Okay, example 8, or number 8. This one, they gave you all the equations. Okay, so you're always plugging in this number in and finding out which one makes that answer. So I always choose the easiest, and 0 or 1 would be the easiest. So if I plug in 0 here, 400 to the 0 power is what? 1. We want it to equal 400. A does not work. 2 to the 0 power is what? 1. And 400 plus 1 is 401. Not the answer. 2 to the 0 power is 1. 800 times 1 is 800. Again, not the right answer. 2 to the 0 is 1, and 400 times 1 is 400. Therefore, D is my answer. So all you're doing is plugging a value. You want to plug it into all of them because sometimes 2 will work, and then you're going to want to try the next one down and see which one makes it true. Chris, can you please sit at your desk? What was your question?
So you plugged in 0 to each of them?
So I'm plugging in 0 up here for X in all of these to see which one will make 400. So like this one made 1, that one made 401, that made 800, and this one made 400. There are some times where 2 of them will make 400, and then you'd want to go to the next one, like the number 1, and see which one worked.
So if I use 1, it would have to equal 800?
Exactly. Okay? Other questions on example 8 or number 8? Okay, number 9. Is my exponent by itself?
No.
What do I do to get it by itself?
Divide by 2.
Good. Divide by 2 to both sides. I have x to the 1/2 power equals 3. How do I get rid of my 1/2 power? Good. And whatever I do to one side, I do to the other. So here, these cancel out, and I get x equals, and 3 to the 2nd power is 9. Are we good with 9? Okay, 10. This is where you need to get common bases. What base do you think I would use on number 10? 3. How will I write 9?
3 squared.
Very good. 3 to the 2nd power, and you multiply it by the exponent that's already there, which is 2x. 27 would be 3 to what power?
Cubed.
To the 3rd times x minus 1. Once you have both of the same bases, we cancel the bases out, and we will solve the equations. 2 times 2x is 4x equals, and we distribute, and I get 3x minus 3. Get all my x's together, so I subtract 3x to both sides, and we get x equals negative 3. Okay, you should be practicing these problems with us. There's quite a few of you that need to do well on this test, and you're sitting there like you have no idea what we're doing right now, and you don't have a pencil or anything. Okay, you actually have to try using it on your paper. I know, just having it in your hand is not going to work. Okay, number 11. Okay.
Can we vote somebody out of the class?
Austin, that would be rude. I would hate for you to have to leave.
Oh my god.
Okay.
Looks like you'd be the one voting.
So 125. If we want to get rid of the square root, if I were to square 125, that ends up becoming a pretty large number. But
Can't you put it equal 5 first?
yes, so I change these all to base 5. So I have 5 to the x minus 2 equals, and 125 is 5 to what power? Okay, and then I can still keep the root 5. And there's more than one way of doing this, so it's up to you. So now in order to get rid of that root, I would square everything, right? So when I square here, I'm going to have 5, and you multiply powers to powers. So that's going to end up being 2 times x minus 2. You need to remember that this 2 is going to the 3 and the root.
So you're not changing the base, you're not putting 25?
So I'm keeping, because this exponent is 3, and so I'm changing 125 to be 5 to the third.
But when you square, why doesn't it change 25?
Oh, because like 5 is like with the x minus 2. So since you have an exponent with the 5, you are just multiplying the powers to powers. So it ends up becoming 2 times x minus 2, because the 5 and the x minus 2 aren't separate. They're connected. They're one. And so as long as I multiply my powers to powers here, it actually is squaring that 5. It's just that we're not writing it. Does that make sense?
So you're doing addition on
Right. Well, yeah. Or technically you are, even though it seems like you aren't.
it.
Okay. So then we have to multiply these powers to powers. So you're going to get 5 to the 6th, because 3 times 2 is 6. And then whenever you square square root, the square root goes away, right? So I'm going to end up with 5, which is really 5 to the first. Just one step ahead. It's okay. And then, so now we have to combine these together. And I end up getting what, Chris?
5 to the 7.
Good, 5 to the 7th. So now that you have a single 5 base on both sides, you can drop the bases. And then we're just solving our equation. I would distribute. 2 times x is 2x. 2 times, a lot of people just forget to multiply this 2 to the second number, so make sure you do that. So 2 times negative 2 is negative 4 equals 7. And then what would I do to finish solving? Add 4 and then divide by 2. So we get 2x equals 11, and then we divide by 2. So my answer is x equals 11 over 2. Austin, you're not doing this with us. No, you have the answers written down. Okay.
What if you got 5 over 1?
That's good. 5 and 1/2 is also okay.
So, question, I can't, like, you know how you showed us where the exponent would be like 2 and then it's, or the root would be 2 and then it'd be 1 exponent, and then it would be down for the exponent.
Okay.
Um,
You'll get the same answer.
yeah.
If you square root 5, that means that you're like squaring this 5. What is the square root of 25? 5. So basically, anytime you square a square root, whatever's under that root just comes out. If I were to take the square root of 5 and square it, that's the square root of 5 times the square root of 5. Or the square root of 25, which is just 5. So the shortcut basically is anytime you square a square root, the number just becomes whatever was under the root. Okay? All right, number 12. Shh. So what is my base going to be on 12? What will be the base on 12? 3. How do I change 1/3 to have a base 3? Exactly. You'd bring it to the top and you get a negative exponent. So 3 to the negative 1, there's already an x minus 5 there, so you have to multiply it by whatever power is already there. This is already a 3, so I just keep it as 3, and then you have 4 minus 2x. Now that your bases are the same, you can drop the bases and solve. I need to distribute negative 1 through, so negative 1 times x is negative x. Negative 1 times negative 5 is positive 5, equals, and then we have 4 minus 2x. So now we're solving. We're going to add 2x to both sides. So negative x and 2x makes x. And then we'd subtract 5 to both sides. And x equals negative 1. Questions there? 4 and negative 5. So anytime you have, is that the negative 1? Oh, see how this 3 is to the first power? Anytime you want to bring a number that's in the bottom up, you just give it a negative exponent. Just like if we have a negative exponent, we bring it down. Okay.
Is that like the first
Okay, any other questions here? All right, number 13. Is my exponent by itself? No, what do I have to do to get it by itself? X plus 2 to the 2/3 equals 25. Now what? Good. Raise it to the 3/2 power to both sides. That cancels out. You have x plus 2 equals. And how will I write 25 to the 3/2 power? So, yeah, the square root of 25, right? And then you cube it. And the square root of 25 is 5. And then 5 to the 3rd power is... So that becomes 125. And then the last thing you would need to do is... Very good. So x equals 123. Okay, I think one of the things that people mess up the most on this test is not getting the correct base. Because you know that 8 and 32 are similar, and they'll do like 8 to the 2nd power, 8 to the 4th power equals 32. But that is not correct. Normally, you will always go down to like the smaller bases. So 8 is going to end up being 2 to what power? 2 to the 3rd, and you multiply it by anything that's already there, so 2x minus 8. 32 is 2 to the... Very good. Times 4x. Once you have your like bases, we cancel them out. We distribute our 3, and we get 6x minus 24 equals...
5x times 4.
Which is 20x. Good. Then we want our x's together. So I subtract 6x to both sides. We get negative 24 equals, and 20 minus 6 is 14x. And your last step would be to divide by 14 and reduce if possible. Can I reduce that? I can divide by 2 to the top and the bottom, right? So I end up getting x equals... Perfect. Negative 12 over 7 is correct. All right, what's my base for 15? 2. Okay, and we always, so this is 2 already, and it's 2 to the 1st right now. And then 4 is 2 to the 2nd. But we don't want the fractions, so what happens when I move it up? We get the negative exponent. So we get 2 to the negative 1 times 5 minus x. So Clayton, what's going to happen with this other one, this 2 to the 2nd? I'm going to move it up, and it's going to become 2 to the... Awesome. 2 to the negative 2 times x minus 2. Once we have that, we cancel our bases, and we're going to solve. So negative 1 times 5 is negative 5. Negative 1 times negative x is positive x equals. Negative 2 times x is negative 2x. Negative 2 times negative 2 is a positive 4. And then we're just solving for x. I add 2x to both sides. That cancels. And we can maybe add 5 at the same time. So I have 3x equals 9, and my last step is 2. Good. So x equals 3.
I kind of did it different. Like, instead of doing whole flip it up and then make it a whole number, I turned 2 into 2 squared, and then put the 2 on top to the x minus 2.
Okay.
And then cancel the fractions. Can you not do that?
Did you get the right answer?
Yeah.
Let me look at it later. I don't know if it'll always work, so I just need to look and see. But there's a chance. All right. Any other questions? Number 16. Okay. There is a question just like 16 on your test, which is why I have it on your group quiz. This one is a little tricky, so pay attention. If you're not listening at all, please pay attention now, because I want to make sure you guys get this. If you noticed on most of your problems, this exponent was always a fraction, and you had 2 numbers and you divided it. Well, this time they didn't write it that way, okay? But you still have to end up doing that. So when you read through here, it says a certain bacteria population doubles every 6 hours. If you start with 50 bacteria, how many will there be in 3 days? Okay, so, well, what's the a value? That one's pretty easy.
50.
50 times 2, and then to the t power. T is time elapsed in hours. What they're saying is that over 3 days, every 6 hours it doubles. Okay, but these, you're dealing with hours and days. So you, first of all, you need to change days into hours. So,
72.
good. So you'd go 24 times 3, which equals 72 hours. So over 3 days, there's 72 hours. And they're saying every 6 hours is when it doubles. So what would you do?
Divide by 6.
Good. So in order to get the t value, you have to go 72 divided by 6, which is 12.
Could you kind of think of it as a half-life almost?
That's exactly what it is. So you could even count, if you wanted to count up. You have 6 hours, that's 1. 12, 2.
How do you know that the 6 goes on the bottom? It should probably be, shouldn't it?
Because since it's over 3 days, you're trying to figure out how many 6-hour periods are in the 3 days or the 72 hours. So that's how you know to divide. And normally it's the bigger one over the smaller. Okay, and so wait, I feel like, so then we go 2 to the 12th power. And if you do that in your calculator, you would get 4,096. And then you just go 50 times 4,096, which is 204,800. And that's bacteria.
That's a lot.
Mm-hmm.
Are we going to get a big number like that on the other one?
You might. Are we okay with 16? Does that kind of make sense? And again, always just kind of pay attention to your units that you have, that days and hours. You want them to both be days or either both be hours. Those kind of things.
It just depends on what's easier.
Mm-hmm. All right, 17. What's the first thing you need to do? Is your exponent by itself?
Divide by 3.
Okay, so we divide by 3.
And then that equals 8.
X to the 3 halves equals 8. Very good. Then,
Times 2 over 3.
good. These cancel. How do I rewrite 8 to the 2/3 power?
It would be 3 on the outside, 8, and then 2 squared.
Okay, and what is the cubed root of 8?
That would be 2.
2. And then 2 squared is?
4.
So x equals 4.